All right, ladies and gentlemen, welcome back. So where does this sort of redox oxidation fit in with that cellular respiration? And what do I need you to get out of it? Is really these ideas of these electron carriers, right? So that oxidation of glucose is going to happen in a series of steps. It's not going to happen in a single chemical reaction. So in order to facilitate that oxidation, that moving of electrons, I need things to be intermediaries to hold on to those electrons in the meantime. And so one of the biggest electron carriers we're going to see in cellular respiration is the NAD plus reduction oxidation NADH. All right, so this is nicotinamide adenine dinucleotide. It's a mouthful, right? We're going to shorten that and just call it NAD+. It's an electron shuttler. It's a coenzyme. It's going to function as an oxidizing agent throughout the cellular respiration process. So what we're going to do is take this crazy looking molecule here. All right, this is that NAD+. And it's got that plus sign right here. All right. And so we're going to pull off hydrogens from the food that you're consuming. We're going to look at it mainly as glucose, but we can pull it off of amino acids, we can pull it off of fats as well. And so we're going to take those hydrogens and reduce that NAD plus into NADH, all right, by tagging on this extra hydrogen here. You see it? So it's not over here, but it is here, and so that gets rid of that plus sign. Okay, so this is the reduced form, this is the oxidized form. And so by pulling off those hydrogens, I'm going to yank off electrons, yank off H pluses, and attach them here. And that's going to become a really big deal when we get to talking about how your electron transport chain works, because I'm going to use those electrons and use those H pluses to ultimately create a hydrogen gradient that's going to allow me to create that ATP that we're going to see later on. So this process here is going to be driven by yet another molecule here, these dehydrogenase. It's an enzyme, all right? And its whole point is to be able to pair hydrogen atoms from some sort of substrate. We're going to talk mainly glucose, and then attach it to this NAD plus to ultimately create the NADH, all right? And again, the NADH then is going to get moved to our ETC. This is your electron transport chain. It's a shorthand way to write it that we'll use then to ultimately create the ATP as we work through the process of cellular respiration. So speaking of that electron transport chain, I'm going to give you a really brief glimpse as to what it is and why it's so important. All right, so when we look at cellular respiration as an overall process, it's a huge number of chemical reactions. It's a huge pathway. And the reason for that is we need that electron transfer to happen in small pieces so that I can actually harness that energy into those ATP molecules. So the amount of free energy that I would get from hydrogen and oxygen and water would be explosive. If I were to try to break down glucose in a single chemical reaction, you would literally spontaneously combust. The amount of heat and energy coming out of a single breakdown of glucose all the way down to those bite-sized energy molecules we're trying to accomplish, it's insane. All right, the amount of free energy change that we make. We'd never be able to harness it. Like I said, you would literally spontaneously combust. So your cells have evolved this electron transport chain to take that breakdown of glucose and do it in a series of steps so that we can control the amount of free energy that's given off at any given point in time. All right. Ultimately, that oxygen is going to be what we talk about as your final electron acceptor, which is what you're seeing down here. All right, so we're going to throw these electrons and these hydrogens through this electron transport chain. We'll ultimately still end up with those electrons and hydrogens at the end of the chain, but because I've controlled the release of the energy through a series of chemical reactions, I'm capable of actually storing it in that ATP molecule but I still need some for those electrons and those hydrogens to go at the end. So we're going to ultimately attach them to oxygen to create water as a final byproduct of this.